Welcome. Today I'm going to introduce you to our paper on staff layout analysis while using the YOLO platform. First of all, what we are trying to achieve and what we are building on. So the most used currently publicly available tool for layout analysis is from Alexander Bacha. And our problems with it come from the fact that it runs on Python 3.7, which is an outdated version of Python, and it also uses TensorFlow, I think 1.13. And this version is no longer supported. There's a new version 2.x. So we are trying to build on these tools and make it work in with current tech. So this is the overview of our pipeline. We are trying to detect the largest music layout objects that we can possibly do, like staff, grant staff, and systems. The purpose of this is to take the big image, like a full page of music annotations, and split it into logical parts. For example, here you can see staff being detected, and then use these data in other OMR tasks like end-to-end music recognition. So what we are trying to detect. Staff can be later used to recognize notes and other smaller objects. Grant staff, because sometimes piano grant staff cannot be separated to staff, so we have to separate them completely to later use them in other models. Also, systems, because they are really important for reading order on that page, and staff measures and system measures. So these are the 5 objects that we are trying to detect. We are using multiple existing publicly available datasets like Audio Labs version 2 and OSLIC, which are both printed pieces of music, and together they have around 6,000 sample images with annotations. Also, for handwritten music, we are using Muscima++, which has 140 samples. But the datasets used don't have systems and grant staff annotated, so we manually edit those annotations. They are now publicly available for others to use. And we created a whole new dataset because the YOLO platform, which we are using, the model platform, states that for best results, 1 to 10% of all training data should be blank or like negative images to eliminate false positives. So we took around 1,000 sample images from Moravská zemská knihovna, which are just empty pages, some tables of contents, covers, back covers, title pages, something you can come across in music analysis, but it is not like a music itself. So this is our dataset overview. We got around 7,000 images in our training datasets. And the most important and interesting part is that the problem with these datasets is that it is really heavily piano oriented, meaning that 98% of grant staff are also system. Okay, so we did some experiments to evaluate our model's performance, and the most interesting result is that our model runs almost 26 times faster than the model implemented by Alexander Bacha. We got around 83 milliseconds per image while running on CPU. The input size of the images is 640 by 640 pixels. Also, the memory requirements dropped significantly from 2020 megabytes for the RCNN to just 50 megabytes for the middle-sized YOLO model. We are trying to evaluate these models both on MAP50 and MAP50 to 90, which depend on intersection over thresholds, intersection over union thresholds from 50 to 95. So the second metric is like more strict on the evaluation. We can see that when we evaluate in domain, the models perform more or less the same. But when we go to out of domain evaluation, YOLO gets better results in the second metric. So when the metric is more strict, the results are comparably good. But here, this gives us big hopes for possible feature zero-shot evaluation. As you can see, the model has never seen handwritten music before, but it performs significantly better than the older model. For example, for grand staff, we got about 5 or 6 times better results. Also, we came across this problem when in the 98% of cases, as I mentioned before, systems are staff, grand staff, which means the bounding boxes overlap by 100%. And sometimes the RCNN model would predict these classes significantly worse. As you can see in the red rectangles, these predictions are a little bit off, and sometimes they even go below 1.5 confidence. The YOLO does not exhibit this behavior. We did not investigate this any further, but our assumption is that it has to do something with the like the pre-processing for the RCNN model. Yeah, before class predictions are made. So here are some future directions and future work. We want to extend the training dataset by adding more music, especially handwritten music. Probably, or we'll use Jirka Mayer's Smeshtima, which is a handwritten music synthesizer, which is currently in development. We will ask for EDIROM dataset, and we would like to run the tests with YOLO, other YOLO sizes. There are in total there are 5 model sizes. We use the middle one, and we want to run these experiments also again with YOLO V11, which is the current state of the art, which released like 2 months ago. Also, we want to run this as a web service on Lindat for anyone to try. Okay, so that's it from me. There are some conclusions. The pre-trained models are available at GitHub with all the source code. It is being developed publicly, so you can find it there. Thanks for your attention. Hope it was interesting.
Thank you very much. It was indeed very interesting. And Alex is really happy that someone continued his work. Yeah, let's open the floor for questions. Yes, Daniel, please.
What input resolution did you use to train your YOLO models?
Yeah, it's 640 by 640 pixels. You can use larger input resolutions, but we came to the conclusion that this is enough for such big layout objects.
Antonio?
Yes, great work. Just one thing, are you planning in the development of your project to include transcription and see how transcription behaves with your system, with the crop systems from YOLO?
Yes, yes, it is. It is planned to do this.
And maybe on that note, I'm basically doing exactly the same right now. I have a transcription system, but need the document analysis. So maybe later we can discuss this in the breakout session. Would be perfect
Okay,
match.
surely we can.
Any other questions? I guess I would just want to know more a bit why it didn't perform as well in MuSchema, because while you say that, yeah, like the model hasn't seen a lot of these like handwritten examples, I would think that they look quite similar. The stuff, like the layout looks quite similar again. Because at least for object detection, all the models perform really well in MuSchema++. So I'm just wondering, where is this stemming from?
I don't really know. I did not investigate this.
I can take this one, I think.
Yeah.
Yeah.
MuSchema++ staff lines and staffs are straight. They don't exhibit issues with handwriting, but everything else is not straight. So if you this is out of domain evaluation. It has never seen this non-straight stuff in training. So probably the issues come from the interaction. Even though like the symbol itself is what the model has seen before, its context is not. So like you get weird stuff in coming into the convolutional filters, which never learned to interpret crooked lines.
Do you think it also could come from the proportions of the image? Because MuSchema is more like wide, longer stuff lines, whereas you have. So I'm just wondering, like, was a training set only like looking one sort of way, which I think that's what we saw in the examples.
This one is for Vojta.
Yeah. That's true. The orientation of the pages is like the exact opposite. But the model like doesn't. The scale is kept the same. So maybe this could be the issue. We'll have to investigate this further, probably.
Okay, thank you, Alex.
Yes, one short question. If I remember correctly, the EduRoam dataset, the Freischütz that you mentioned, it only had measure annotations for like staff measures. So it didn't have like individual things. How would you incorporate this dataset into this training if you only have like partial annotations?
Well, we actually had partial annotations in the datasets that I mentioned before, like Audio Labs and the OSLIC dataset. No, OSLIC MuSchema, and I added those. Like manually. So I wouldn't probably use the dataset if it was incomplete for my training, but I would try to add those annotations.
Just jump in. There is a difference because Audio Labs had annotations of individual staffs, and we built the systems by just grouping them. So Wojtek would just annotate like 1, 2, 3 are one system, 5, 6, 7 are second system, and it was quick. But with EduRoam, you have the system measures, but you don't have the individual staff measures. So splitting up would be very difficult. And but we've got a pre-trained model, so we could maybe like pre-annotate it and then just correct it, something like that. I don't know.
Yeah, probably bootstrap it right from the existing model.
Yep.
Well, thank you once again.